All right, so I'm not going to call this senior analyst because someone made a comment about being senior earlier, and I don't. All right, so, this is always a fun part. I think, Charlie, you participated last year, right?
I think so.
In the closing, and Ian too, right?
2 years ago.
2 years ago.
I got a pass last year.
All right, well, we brought you back. And Caroline and Dean are new. Caroline is a former colleague of mine at Heavy Reading, and she went off and did some other jobs since then. But maybe if you could each take a moment, Caroline starting, introduce yourselves and kind of your coverage areas, and then we can jump into some of the questions and talk about the takeaways. So, Caroline.
Okay, thanks, Dan. So, yeah, Caroline Chappell. I have my own company now called CCSquared, and basically looking at the future of networks, but quite a long way out, 5 to 10 years, and of course, I'm very interested in how AI is going to have an impact on that.
Charlie?
Charlie Reed, ATLANTIC-ACM. We're a small company focused on everything networking within the U.S., from infrastructure all the way to, overlay services, and I sort of cover all of it, from wholesale, through consumer services, and size, count revenues, and understand what's going on from technology to competitive analysis, et cetera.
I'm Dean Bubley. I run my own advisory company, Disruptive Analysis, and I do pretty much everything related to telecoms and bits of cloud and IoT, increasingly quite a lot of technology policy stuff as well, and that spans from broadband and spectrum to satellite and 6G and OSS, BSS, and this for me is like another piece of the jigsaw puzzle and looking how everything fits together.
And Ian Redpath, Research Director for Transport Networks at Omdia, and spending a lot of time looking at connectivity for AI recently.
Yeah, and I'd like to start off maybe with Ian and work your way back this way. If you could talk about what would you say are 2 or 3 key takeaways, and it doesn't have to be important for everyone, it could also be just important in the area that you track, but what do you think are 2 key takeaways from the event that maybe we could explore a little bit?
Yeah, sure. Starting with capacity, 100 gig Ethernet with the AI profile. So that's to me, it just seems like a natural evolution, and it fits the bill. You have these training needs you want to burst, but then you don't need to leave it up forever. You can take it down when you don't need it. And then adding the extra performance parameters, so lower latency, getting jitter in there, high availability, and low loss. So that's definitely one takeaway from the event for me.
And when you're referring to the AI profile, you're specifically talking about the plan to certify the Carrier Ethernet for AI profile. Yes. Yeah. And I would have to say, when we put together, our original blueprint last year, one of the key things that I had drawn upon was the discussion that, some of the data or the discussion that you had had with Dave Ward about the transformation that was taking place in the optical and the Ethernet and all of that. We included that in the blueprint, and then also kind of provided an update in our most recent market brief, where we talked about agentic AI and waves and Ethernet. But you touched on the Ethernet. What about the waves?
Yeah, waves is key as well. Now, this kind of shifts the discussion a little bit, going more into the core, so the data center to data center core. So, I mean, there you've got different options, and we've heard some about that in the conference, dark fiber and MOFINs. And, there you're talking about massive bandwidth, like you're into full fill territory, you're into, tens and tens of terabits up to potentially hundreds of terabits per fiber pair, and then they can do multiple fiber pairs. And then in that mix, wavelengths is an option. So that's more of a nailed up, 100 gig volume now, 400 gig is really turning up, and people are talking about 800 gig. But that will fit a particular bandwidth need in a particular situation. So you've got these massive terabit needs, you've got more flexible access style needs, but then you're going to have these wave needs, and that can be where the other higher capacity solutions are not available, or it could be a more regional type cases where, a few waves would do it. And to take that back to NAS, that needs to be federated, intercarrier federation.
Yeah, excellent. You guys want to work down this way? Caroline? What?
My takeaways are more high level, but actually I have three that map to the what I see as the three levels of disruption that AI are going to bring. The lowest level of disruption, it's still disruptive, but the lowest level of disruption is all about how AI is going to drive the need for more automation, and I think we heard an awful lot about that at the conference, and certainly that's the near-term focus, and as it should be, because that's really what's needed to be done. But it's disruptive, but it's really sort of AI is going to force the automation of the business as is. So it's going to make things faster, more agile, and so on, but nothing much is really going to change in the value chain. But I think there's a next level of disruption on the horizon, and I think that was also, there was a very interesting panel this morning, and a little bit of an argument between Daniela and Fahim, and I think I'm with Daniela actually, in that I think as we get to agentic AI, I think we're going to see one of the things that AI is going to do is going to democratize information. And there is always disruption when you break information asymmetries. And I think this is what's going to happen. Every enterprise, large or small, will have an agent, potentially, in the more medium term. And then the agents are going to negotiate across the federations. And I think actually a takeaway here is that you're already beginning, Mplify is already beginning to think about that with this federation idea. So I think that's important for the industry, right. If it's to survive.
So you're referring to the federation panel,
yes.
In which there was a discussion about, do the enterprises sit outside?
Yeah, do enterprises go through service providers, or can they, in a world of agents and a world of APIs and everything being available, will they actually just instruct their agent to go and negotiate,
right.
Directly themselves? So, I think that could happen. So that's going to be pretty disruptive because, what happens to the customer relationship there. But again, big question marks because it's more medium term. Mm-hmm. And then I think we saw a glimpse of the far future and potentially the most disruptive impact of AI in Stephen Howe's presentation from Cognition. Because the most advanced venture capital money at the moment is going into the whole idea of self-improving AIs. So these are agents that can improve themselves, and Cognition is doing that in a very narrow domain, coding, but that's just the beginning. People are working on that now in terms of, self-improving AIs that can do science. And in that case, what happens when, what happens to materials science, and indeed, what's going to be the impact of the network? Now, it's very, very long term, but I think it was interesting to me that all three levels of disruptive AI disruption were represented at this conference. So well done.
Good. I appreciate you doing sort of the nearer term and the longer term. That's really great. Dean.
So, 3 takeaways. First off, it's been interesting to see MCP mentioned everywhere. Way back in the depths of time, so July, I wrote an article about saying MCP looks as if it's the next big thing in telecoms, and it now crops up on an almost daily basis. And so, I think that then feeds into the second theme, which is around agentic AI. And what I would say is everyone is interested in agents and how they're going to communicate, not just inside the network or inside the telecom domain, but across the network. The issue is that I'm not seeing an awful lot of data on how much it's actually being used in the wild at the moment, or how much of it is interesting slideware, and that goes with MCP as well. What I did like was the focus on how do you identify and authenticate agents? And I see similar discussions being held in lots of forums. I don't think that the telcos are going to be the agent identity provider on their own. I think there's going to be lots of different IDPs for agents, and it makes no sense to have a telco doing identity for an internal agent-to-agent connection within an enterprise's IT estate. But I think there's definitely some interesting things where agents do interact across the network between data centers and are tied in with network as a service. The last one I'll mention is the link with mobile and Kamara and GSMA. I know the GSMA Open Gateway and the Kamara project and network APIs on that side of things pretty well. And looking at it, at the face of it, I think I see some synergies. I think that potentially some of the mobile capabilities might end up as payloads within LSO. Things like maybe edge capability, although I'm skeptical on some of the things like Nokia, NVIDIA doing edge at cell site is frankly nonsense, I think. Where I do think the other side of it is I can see mobile operators being customers of Mplify APIs for backhaul and their own data center and VNF function connectivity inside their networks. And the last one is that identity bit. And the GSMA is doing a lot of work on identity and authentication of end users. And I wonder if there's a parallel around the identity and authentication of agents. And I think that's a possible synergy.
Mm-hmm. Yeah, I'm glad you mentioned MCP. I'd be curious how many people in the room knew what MCP was a year ago? Put your hands up. Probably not that many, right?
I think it was one person.
There's one person over there. Anybody else?
It was only announced.
Okay, all right. There are 3 they're claiming. Okay.
I feel
it's pretty amazing, right? And then we already have several demos with MCP, which is fantastic. The speed.
Yeah, it's like everyone's got an MCP server in their demo. As far as I know, no one's actually using one in anger.
Charlie?
Well, that made me feel much better because I showed up. I feel like everyone knows these acronyms, and I'm supposed to know it all, but I was unaware. And I guess my takeaway was, impressed with kind of the advancement of the discussion, essentially, on the AI agents and the acronyms, and kind of seeing some elements, working, whether it be, the demo we just saw, or the stuff that Sage was doing. There's just like some stuff actually happening, and then there's little images of agents in between the APIs, which are just kind of like maybe an agent will help here. So I'll look forward to the clarity on that. So I guess my takeaways, or the things I think about at this conference, is like, how are we making the network run faster and better, and how are we capturing more revenue? And on the first one, I saw incremental and sort of advancements towards NAS, and some of the carriers, Zayo just now, Lumen, AT&T with their express waves are really making an effort and embodying the themes here, and watching the diagrams and the improvements in the internal systems with agents has been impressive, and just means things are moving well in the direction of just improving these monolithic networks to making them more productive for the future. And then for the demand dynamics, right, there's a lot of discussion around attacking the AI connectivity space. Obviously, the hugest piece of that is the thousands of strands of dark fiber that are going in for the training data centers. And then we're just kind of watching where the inference workloads kind of exist and how they communicate with each other, and whether you need Ethernet sort of flexible and on-demand and private Ethernet connections versus IP. And I think it's being figured out. It's helpful to understand everyone's perspective about the distribution of those inference situations and the kind of connections they're going to have, hopefully for a step function of revenue improvement. But I think we're still figuring it out. And I think my takeaway was just various perspectives and some testing around capturing that demand.
Yeah, very good. I appreciate everybody's key takeaways. Yeah, I guess I would sort of point to two really noticeable trends from a perspective of looking at NAS and then AI in shaping the event and in the awards the awards input and all that. And that is, when we launched GNE this is our third event. So when we first launched it, we had tried to identify the number of companies that actually really marketed and sold network as a service. I mean, like next generation network as a service, not the kind that was like introduced a decade ago. And there were very few companies actually that we could sort of say, yeah, these are NAS leaders. Contrast that to the awards program in which we had something like 16 submissions for the NAS Vision Award. The sophistication of the work around NAS has increased dramatically. And then when we decided for the theme for this event, I suggested that we say NAS for AI. And I wanted to make sure that when we had the conversations with the folks around the program, that we got feedback quickly to say, is this the right direction or not, right? So as we went through in the coordination on the different sessions, it was pretty much coming back, this is the right topic to focus on. But it started out as NAS for AI, and I would say probably maybe 10, 15% was AI for networking. And then by the time we were at this event, it's 50-50, right? It's both. And I think Gorkum summarized it pretty well this morning. It's like, okay, you talked about, you've got NAS for AI with connectivity, automation, cybersecurity, and sovereign AI and new services, but it's actually the other way around. And I think that's a key takeaway for me, is the whole story around AI ops. Everybody is sort of looking at how they leverage AI to make things better.
I mean, I see that AI is applicable in all areas of networks and telecoms, whether it's in the radio network, working out complicated beamforming and channel estimation, whether it's in subsea doing analysis of sensing data to look for a earthquake or a ship dragging an anchor and the analytics on that, whether it's on the for fixed broadband, looking at maybe some of it's the customer-facing stuff, the churn prediction, but it can even also be, is there someone with an excavator nearby? Can we detect that from the vibrations in the fiber and the the changing phase, and sort of alert them to stop digging? So I see AI for the network really spanning across this, whether it's in the core of the network or whether it's right on the edge of the access.
Mm-hmm. And I really appreciated the perspective that Sridhar and Chetan had shared from Colt and Google Cloud, right, on the development of what they called NAS 2.0, right, where you introduce the agents into that. That was pretty incredible. What about anything else you wanted to add on Carrier Ethernet wavelengths? Ian, that you're seeing?
Yeah, sure. So this kind of.
I mean, one of my takeaways is 1.6 terabits, but it was also the comment from Paul at Verizon, right, talking about the number of orders that they're getting for the various waves, right? 30. I need 100 gigs, or I need. I can't remember the number he said, 400 gigs.
It's coming, and it's going to be massive. Where we really started to see this first was on the optical component side. So I mean, the GPUs have hogged all the limelight. But back in 4Q23, the short reach optics inside the data center, so the 100 meter to 2 kilometer, the trajectory was like this, and then 4Q23, it just went like that. And it's ongoing, and they're going 400 gig, and they're stepping up to 800 gig shortly and beyond. And all the while this is happening, we're looking at the WAN going, what's going on with the WAN? And the WAN is on a bit of a lag. But the WAN is finally picking up, and Charlie cited a case there, and we're starting to see it roll out different paces in different regions. It's going the fastest in the US, to be sure. And one of the new things that's kind of come out is this concept of scale across. So going from scale up to scale out to scale across. So the original notion was that all the GPU pods had to be in very close proximity to keep your model training efficiency at the highest level, but then just plain old power weighed in and started to, they couldn't get enough power, so they had to go to a distributed model. And by relaxing the model training efficiency a little bit, that's created brand new bandwidth. And what we see there is that the target technology there is 800 gig interoperable PCS pluggables.
Yeah, and I think going further out, there's a lot of interest in the co-packaged optics. I was blown away at an event I went to recently when someone said that for one of the big AI factories, one of the top-end ones full of NVIDIA GPUs, they were saying the power budget for the optical networking in one of these large data centers was 40 megawatts of power just for the optics, never mind the GPUs. And so they were looking for sort of how do we take energy out of the optical layer. And I think that the power side of this is easy to overlook. And I increasingly, when I look at the nature of distributed compute, it's going to where the energy is, whether we're talking gigawatt data center campuses or actually there's a model that I have in mind which is almost like a dumbbell where you've got big data centers at one end and then you also do distributed compute down to smartphones and home gateways at 1 watt or 30 watts or even milliwatts in a light bulb. And actually the bit in the middle, the edge, so-called, is actually the thin bar in the middle, because it's actually difficult to get power to the cell tower or the regional aggregation center for a carrier. It's like you ask a typical operator who wants to do GPU as a service, you say, okay, where's your next gigawatt coming from? And do you have a nuclear energy strategy? And you get blank looks and people looking at their shoes.
Well, yeah, so GPUs, wavelengths, both mentioned there. I thought it was fascinating, the data that was shared by the slides from Ethan and Dave from Lumen. And I wrote it down. Transferring 1 petabyte of data for AI training can reduce the cost by 40x with 400 gig versus 10 gig. I mean, that's like really eye-opening. And I think one of the speakers this morning, gentleman from Arista, had talked, or this afternoon had talked something similar in terms of the capacity and at least on the time savings, right?
Yeah, and so, just to add a little bit on the scale of the bandwidth, right? So the hyperscalers have committed to $22 billion of dark fiber. That'll probably double, and that's buying them like 1,000 strands on long-haul networks, which each strand carries like 50 terabits. So like the amount of data that they're requiring is not something that like my brain can really wrap my head around. Yeah. And so it's really huge. And so when you think about the demand and there's that hyperscaler chunk, but then there is going to be like the neo clouds and the application providers that will say like, oh, I don't quite want dark fiber, but give me 40, 100 gig waves. And I think that identifying that opportunity and kind of jumping on it, within the landscape of AI demand will be really interesting. And we haven't quite seen it. Waves are not growing 20% yet, but we'll see next year whether that's the case. And I think just to kind of, as we think about the future of the networks just in the US, right, the hyperscalers will own most of the fiber and have connectivity between the data centers. And so it'll be important, they'll never have last mile, but as we look at kind of the workloads that we're talking about, they're happening between data centers. So it'll be important to, just watch them and make sure they don't kind of like take the industry away or take some of what the telcos can do from cloud connectivity. But I think the amount of network that they are accumulating is just unreal.
Yeah, it's interesting from the standpoint of the hyperscalers, but also just the distribution of the data centers moving further out into regional. Go ahead, Carol.
Well, I was going to say that I think it's important at this particular point in time to to think of other possibilities as well. And I think some of the data center providers already are. It was a VP at Digital Realty that's really watching with interest neuromorphic computing, which Gurkan mentioned this morning. And I think we need to be aware that things are not necessarily, particularly with AI, and particularly with the possibility of self-improving AI, things are not necessarily going to go on business as usual. And actually, if you think about, people are throwing around 40 gigawatts or whatever, where is this power going to come from? Where is it? Where's the water going to come from? you know, more importantly, even than the power, because the power, there are a lot of sources, you know, and maybe Jensen Huang will crack nuclear fusion, you know, so who knows. But I think a lot of people are very worried about this.
Yeah.
And,
so you think something may come along that disrupts the picture?
I think there could
from
be
an energy
disruption.
efficiency point of view. And I had a side conversation here.
Yeah.
Actually, last night, someone was saying they're talking to companies about this type of work to make sure that we've got other options.
And the data centers that are being built, these massive, what's it called, Stargate or whatever, that could be the Rust Belt infrastructure of tomorrow.
Yeah, it's like sort of,
Whoa, that's almost an ending quote.
I mean, because you've got neuromorphic, I've been following the evolution of analog compute for certain problems, various forms of quantum compute, but also sensing and everything else. Collectively, I'm starting to use the term post-digital, largely because it means that I get to argue with all the people who talk about digital transformation. Actually, well, we've had digital comms since 1842 and Morse. Let's stop living in the past century.
Well, we had a debate about whether we should use the AI economy or digital, and I think AI won.
Yeah.
So,
good.
Right? I didn't want to leave the cybersecurity topic off of the key takeaways. You all can chime in here if you want, but I did want to. I thought one of the key quotes was, "Quantum computers are 5 years." The quote goes, "Quantum computers are 5 years away from the past 20 years." Which I thought that came from Dave Kettle at ARKit. Any comments on what you're seeing on the cybersecurity? Any key takeaways? I know we got to wrap up.
Well, I think I like the ARKit solution actually because it's not quantum.
Yeah.
It can be used now. So I think that the practicality of that is we've got to think about.
I just say I know enough about security to know that I don't know enough about security.
That's an honest.
Yeah, I would just say that, the attack. It was interesting with like Palo Alto and others are kind of creating a new security category of AI security, which will make a ton more money. And I would just say the challenge of containing, these different AI agents will be very big, and some people will make mistakes. And I think it's something that should be well known.
In revisiting this digital word, the digital infrastructure is at risk. Organizations must start post-quantum migration now. I think that came from Ettore. Yeah. Something similar to that, right?
Yeah.
So with that, I think we need to close things out. I appreciate everybody hanging out with us, and just thank you for the panel.
Great. Thank you.